So today we are going to discuss chapter 17, Waves 2. The chapter title is Waves 2. In this chapter, we are going to only focus on sound waves. So my dear, in chapter number 16, we studied the general information about the wave, and we studied what is wave equation and what are the parameters in the wave equation. We studied what is the calculation for the speed of the wave. We studied how to calculate the speed of the waves on the string. We calculate the general formula for finding the wavelength. We find how to find the frequency of the standing waves. Am I right? And also we calculated how to find the power of the wave. All these things we studied in the chapter 16. In this chapter, what we are going to study, we are going to only focus on the sound waves. Clear? So I just move the slide. These are all the contents today we are going to discuss in this chapter. What we are going to study, first I am going to give some introduction about the sound waves. And then we are going to study the speed of the sound in air at a different temperature. Actually, don't get confused about these two. The second one is the speed of the sound in air at some particular temperature, because when the temperature change, your speed of the sound will be different. In the third point, the speed of the sound in different medium. What are the mediums we have? We have solid medium, liquid medium, and air medium. So we have some formulas. And then we are going to study the interference of sound waves. In chapter number 16, we studied the concept of superposition principle, and then we studied two cases, constructive interference and destructive interference. Am I right?
Yes, Doctor.
Yes.
So
Yes.
in this chapter, we are going to study what is this interference of these sound waves. So we are going to only focus on sound waves. And then the most important topic, we are going to study some information about the sound intensity. And in this topic, we are going to learn how to convert that sound intensity in terms of decibel. And for sure, some questions will be there in your quiz one and in your midterm exam. So please listen carefully. And we are going to calculate what should be the sound waves in tubes where the tubes closed at both ends. For example, in this topic, we are going to take a tube and you are going to take the two ends of the tubes must be closed. If two ends will be closed, what will happen? Sorry, open. My dear, listen carefully. Actually, this is open at both ends. I just made some mistake. Just a minute. I can just open at both ends. It's not closed. So the tubes opened at both ends, and the second type, you have a tube. One end is open, another end is closed. So here we are going to study the same thing what we studied in chapter number 16, how to calculate the lambda. If you have sound waves inside the tube, how to calculate the lambda. And finally, we have to conclude the session of this chapter with Doppler effect. Clear? Clear? Yes. So these are all the contents today we are going to discuss. Let's start from this picture. My dear, in this picture, you just see the picture, we have the ears. We have the ears, and inside the ears, we have some small organs which will be responsible for sending the waves to the brain. For example, when you hear some sound, the sound will go to some organs inside the ears. So in this place, you have some eardrums, many things are there, and then this will send the signal to the brain, and then only we will observe, we will know what type of sound we will hear. Okay, so today what we are going to do, first of all, we are going to study the introduction of the sound waves. Actually, we studied in chapter number 16, we have two types of waves. When you classify the mechanical waves into two types, you have longitudinal wave and transverse wave. Your longitudinal wave is an example. If you want to give some example for the longitudinal wave, you can just give the sound wave, because sound waves, the displacement of the particles moving parallel to the direction of the sound waves. So if you just see this picture, what you understand from this picture, the sound waves are isotropic in nature. Have you ever heard the word isotropic?
No.
Have you ever heard the word isotropic?
No.
Huh? My dear, isotropic means equal distance in all directions. For example, you can see this picture. Here, this is the sound source. For example, you consider this is me. So I am just talking to you now. So you have the sound source. When you emit some sound here, what will happen? The sound will be travel in all direction at equal distance. For example, here how many rings I have? I have 1, 2, 3, 4, 5 rings I have, and each ring has some different radius. Am I right?
The same value, yes.
Yes. For example, here 1, 2, 3, 4, 5, 6 persons they are sitting. So here the sound waves is here. Okay, the sound wave is here. When the sound waves emitted from the source, all the 6 persons they can hear the sound waves perfectly. That means the sound waves travels isotropically. Isotropically means in all direction with equal distance. Clear?
Yes,
Yes,
doctor.
doctor.
So the sound waves is just nothing but it's an energy flow. So that things are given in this slide. So two things you have to remember. The example for longitudinal wave is the sound waves. When you just emit some sound, what will happen? The sound waves moves isotropically. When you just come for this slide is purely theoretical concept. What is given in this slide? Here I am just giving the movement of the sound waves. So you can see here some part of the particles are compressed and some parts are rarefied. Some parts are compressed, some parts are rarefied. So in chapter number 16, we just give the picture. So when the sound waves are moving, some parts will be compressed and some part will be rarefied. Some parts will be compressed, some parts will be rarefied. Am I right? So if you want to calculate the wavelength, you have to take any two consecutive compressed region, or if you want to calculate the wavelength, you can just take any two rarefied region. Now what we are going to study from this slide is just we are going to explain the longitudinal wave in terms of pressure variation as well as the displacement, because it will be moving parallel to the direction of the propagation. Now if you just see here, wherever you have the compressed region in this place, the pressure will be more. Wherever you have the rarefied region, that means the relaxed region, you will get the low pressure region. Now the pressure terms depends on the pressure terms of the wave depends on the speed of the wave, the density of the medium what you are going to take, and then angular frequency multiplied by its amplitude. Because why we just write is the sm is nothing but displacement point of view. Clear? So whenever you have the sound waves you can express the longitudinal wave in terms of displacement wave as well as the pressure variation. So these two are very, very important, and there is no information apart from that. We have to just only get these two information. Understand? We are not going to solve any question related to this. This is just for the theoretical idea. Clear?
Doctor,
Yes.
before this slide, you mean the direction is perpendicular for traveling sound?
My dear, transverse wave, the particles are moving perpendicular to the direction. Okay, this is sound wave. Sound waves is an example of longitudinal wave. It should be moving parallel.
Yes. Longitudinal.
Clear? Don't get confused. Okay.
Yeah.
Okay. Now what we are going to do in this slide, we are going to calculate the speed of the sound in air at different temperature. My dear, whenever the temperature increase, for sure the speed of the sound will increase. So what is given here? The speed of the sound in air changes with change in temperature. For example, here I have a formula. If you want to use this formula, you can easily find what should be the speed of the sound in particular temperature. Now you can see, let's we take 0 degrees Celsius. Let's we take 0 degrees Celsius. If you convert the Celsius to Kelvin, what you have to do?
Multiply by 273.
273.
Not multiply, you have to add. Okay, don't make mistake. So you have to add 273. So when you add 273 to this Celsius, you will get the answer in terms of Kelvin. Am I right?
Yes.
So if you want to use this formula, the most important thing, 333 square root of T over 273. So you have to use this formula, and the unit for the speed is meter per second. Now, whenever you want to substitute the value of this temperature, what you have to do? You have to take the temperature only in terms of Kelvin. For example, can you please substitute this value here? If you substitute this value, when 0 degrees Celsius, you will have the speed of the sound is exactly 331. Am I right?
Yes.
Okay, let's go for 30 degrees Celsius. If you have 30 degrees Celsius, convert this 30 degrees Celsius to Kelvin. You have 303. Am I right?
Yes.
Yes,
Substitute
right.
the value here. V, which is equal to 331 square root of 303 over 273. If you just work out, your value will be closer to 348. Am I right?
Yes.
Yes.
Yes, you're right.
Better I can just work out with one more time. I think if you have a calculator, you can just calculate.
It's gonna be 390.
348.7 meter per second. Am I right?
Yep.
So what you observe from this in this slide, so whenever the temperature changes, the speed of the sound will be changed. Actually, the speed of the sound is a constant value, so don't worry about the speed of the sound values. If you have any questions related with this, for sure we will give this value. Understand? So what exactly happens if the temperature changes? What is exactly happens? We already studied in chapter number 16. What is the sound wave? It is nothing but the vibration of the air particles. Am I right? The molecules in the air, it's vibrating. Am I right or not?
Yes,
Am I right or not?
Yes.
So if temperature will increase, what will happen? The molecules in the air moves faster. When the molecules in the air moves faster, what will happen? The pressure of that particular area gets higher. So when the pressure goes up, what will happen? The waves will move quicker. When the waves will move quicker, your sound waves will be travel faster. So this will be the flow chart which explains when the temperature rises, your speed of the sound will be higher. It will be moving very faster. So we can use this formula to calculate the speed of the sound at different temperature. So in this formula, if you want to use this formula, you have to take your temperature in terms of Kelvin. Clear?
Yes.
Yes.
Okay. Let's come for the third slide. What is given in the third slide? In this slide, we are going to study what is the speed of the sound in different medium, because we have three mediums right now: solid, liquid, and gas. Am I right? Am I right or not?
Yes.
Yes.
So if you want to calculate the speed of the sound in different medium, you have to use this formula. What is the formula? V, which is equal to square root of B over rho, where B is the bulk modulus. You already studied the concept of bulk modulus in chapter number 12, physics 1. Am I right? We already studied this formula. Do you remember this formula?
Yes.
Yes.
Yes,
We studied in chapter number 12, bulk modulus, Young's modulus, shear modulus. So if you want to use this formula, you have to use this formula for finding the speed of the sound in different medium. For example, I have some example here. So in this slide, I gave some example. If you pass the sound waves in water, what should be the speed? For example, I use this formula V, which is equal to square root of B over rho. So what is the bulk modulus of the water? This is the constant value. So the bulk modulus of the water is 2.1 multiplied by 10 to the power of 9. And then the density of the water, which is equal to 1000 kilogram per meter cube. So both are constant value. When you substitute these both values in this formula, what answer you got? You got 1449 meter per second, which is approximately 4.4 times of your sound waves in air. Am I right?
Yes.
Yes,
Because
right.
generally the waves value is 348 multiplied by 4.4. You can just check. If you just check, your value will be closer to 1449. So you can observe from this slide, if you pass the sound through water, that means the liquid medium, the sound waves will be travel 4.4 greater than the speed of the sound in air. Okay, let's become for metal. That means in solid medium. If
Doctor,
you take an example of any solid medium, here I gave an example
What
of
does B
steel
mean,
material.
doctor?
What, my dear?
What does B mean?
Which one?
B.
B is the bulk modulus. Bulk modulus. Do you remember that in chapter number 12 we studied?
Yes, bulk modulus and shear modulus.
Maybe I think you forgot, huh? My dear. Actually, we studied the concept of bulk modulus in chapter number 12. Actually, the formula says V, which is equal to square root of bulk modulus of the material divided by the density of the material. So here, what material we take? Steel material. So each and every material has its own bulk modulus value. If you take copper, copper has bulk modulus. If you take iron, iron has bulk modulus. If you have aluminium, aluminium has bulk modulus. So, and also it has some density value. So each and every values which have this constant value of bulk modulus as well as the density. Understand?
It will be given, Doctor, in question.
It will be given. It will be given. No need to, don't worry about the constant. The constant value will be given in your exam paper.
okay,
Clear?
Doctor.
So, Doctor, in the exam, we have to take the models from the question and put it in the
Formula.
yeah. Only that.
That's it.
Okay.
That's it.
Doctor,
Okay.
this
So,
mean the sound waves in the water are faster than in the air?
my dear, it will be faster first in solid, then it will be moving in liquid, then only, yeah.
Yes.
You can just see, my dear, what if you just substitute these two values in this formula, what answer you got? (2740 meter per second), which is approximately 2 times greater than the speed of the sound in water. So what you understand from this, the sound wave will be travel more in solid, the second one it will be travel in liquid, and third one will be in air.
Yeah.
Understand?
Yes.
Yes,
Yes.
it's clear.
So please don't forget about the formula. Formula is very, very important. Okay?
Doctor,
liquid
Yes.
include the gas, right?
Gas is nothing but air.
The gas with liquid,
My
right?
dear, gas is nothing but your air. Air medium is nothing but our gas medium. Am I right?
I think the gas is liquid.
الهواء غاز.
My dear, air is an example of gaseous medium. Liquid is an example for our water medium. And solid is an example for different material. Steel, iron, gold, whatever the things we have, it comes under the solid. Understand?
Okay, understand.
Okay.
Yes, teacher.
Yes? It's clear?
Maybe when someone asks.
What is your question, my dear? Anybody have question?
No, teacher. Yes, everything is clear.
Okay, that's clear. Okay, let's come from this. Just have a look of this slide. What is given in this slide? We are going to find what is the interference of the sound wave. My dear, can you please write what is the formula for the displacement of the wave? The displacement of the wave should be written as Sm cosine of kx minus omega t. Am I right? We studied this formula in the third slide. And here, this kx minus omega t is your phase. We already studied this concept in chapter number 15. If you take a wave equation, this phase plays an important role. So now in this slide, what I am going to do, I am going to explain what is the interference of the sound wave. So if you just see this picture, I have two sound sources, S1 and S2. And I am just standing in the point P. And you can see when you are standing at the point P, these two sound sources will produce some sound. You can hear these two sounds at the same time. Am I right?
Yes, you are right.
Am I right?
Yes.
So the distance from the sound source 1 to U is exactly L1. Likewise, the distance from S2 to U is L2. So now what I am going to do, I am going to take only the phase from the equation. What is our phase? This is the phase. So for the first sound waves, I took, this is my phase. What is my phase? K, x is our distance. What is our distance here? L1, am I right? Minus
Yes.
omega t. I can write like this, am I right? Am I right or not?
Yes, you are.
Yes.
Likewise, for the second sound waves, I can write the phase phi 2, which is equal to k L2 minus omega t. Now what I am going to do, I am going to take the difference of these two. So if you take the difference, what you will get, my dear? Phase, the resultant phase, which is equal to phi 2 minus phi 1. Am I right? Am I right?
Yes, you're
Yes.
right.
So now take this value and substitute here. If you substitute, what you will get, my dear? Phi, which is equal to k L2. I'm extremely sorry for this. Phi, which is equal to phi 1, which is equal to k now resultant. My resultant phi, which is equal to phi 2 minus phi 1. So I am going to take this value and take this value. I am going to substitute here. If you substitute, what you will get? Phi, which is equal to k L2 minus omega t minus of k L1 minus omega t. Am I right?
Yes, you are.
Now just multiply this minus inside. What you will get? K L2 minus omega t minus into plus minus. Am I right? So
Yes.
K L1 minus into minus
Plus.
Plus.
plus omega t. Now you can see this plus omega t and minus omega t is cancelled, and finally I got phi, which is equal to k L2 minus k L1. Am I right?
Yeah.
So I can take this k outside. If I take the k outside, what I will get, my dear? My k, if I take k outside, what I will get? L2 minus L1 inside. Am I right?
Yes.
What is L2 minus L1? My L2 minus L1 is delta L. Am I right?
Yeah.
And here I have phase. So what is k, my dear? I think we already studied in chapter number 16. What is
2
k?
pi over lambda.
2 pi over lambda.
2 pi over lambda. I am going to take this value. I am going to substitute here. Therefore, my phi, which is equal to 2 pi over lambda delta L. Am I right?
Mm-hmm. Yes.
Am I right?
Yes.
Yes,
What you got here? What you got here?
The same.
Same. So what is this? This phi is the phase difference, and this lambda is the 2 pi over lambda is the path difference. So what you understand from this? You will get some 1 mark theory question. Write down the relation between phase difference and path difference. So if you have this question, you have to write this relation. What is the relation? Phi, which is equal to 2 pi over lambda multiplied by delta L. So this is my path difference. This is my phase difference. Clear?
Clear, yes.
Okay, now if you want to get the constructive interference, this will be the rule. So what you understand here, m is the value which start from 0, 1, 2, 3. Could you please substitute 0 here? What you will get? 0. If you substitute 1, what you will get?
2 by
And 2,
4 by
6 pi. That means you will get the even phase difference. Am I right? Even path difference. Am I right or not?
yes.
Okay, if you substitute the value here, what you will get?
0. No,
Zero.
1.
1 pi.
By.
Here.
5 pi.
3 pi. 5 pi, it will be going. So you can see here, if you got an even phase difference, what you will get? You will get the constructive interference. If you got odd, you will get the destructive interference. Understand? These are all the theory question. We don't have any question from this slide. This is just a theoretical concept. Okay?
Okay. Doctor, also
Clear?
with the rules or will come in?
Yes, actually you have to memorize the rules. Maybe sometimes in the objective types we can ask this question. For example, in the quiz, I can write down the correct relation of the phase difference and the path difference. So you have to see what answer is given there.
Phase difference, it's equal to the path difference, right?
Yes.
Yeah, okay.
Clear?
Excuse me, Doctor.
Clear.
Yes.
I understood the first part, but I still have some doubt in the second one, the constructive
What? Where?
and the circle, the constructive and destructive interference.
You mean here or in the previous chapter?
Here in this
Okay,
chapter,
what's your question?
I didn't understand the addition and the subtraction for the phase.
My dear, this is basic, small calculation. My dear, you have two sound waves. Am I right? Am I right or not?
Yes,
Each sound wave has the phase. Am I right?
yes,
So I took only the phase of the sound wave equation. Okay. So what is your sound wave equation? S, which is equal to Sm cosine of kx minus omega t. This is the wave equation. Am I right? Sound
yes,
wave equation. Am I right or not?
yes.
So I took only the phase. So here x is the distance, but here what is my distance? That's what I replace this x with L1. Do you get my point?
Yes,
That's what I just write the phase 1 for the first source. Likewise, phase 2 for the second source. This one. Clear?
okay,
So I find the difference between these two phases. I got this equation. Clear?
yes,
Take this value, substitute here. Likewise, take this value, substitute here. When you substitute here, you will get this equation. Am I right?
yes,
So I take k outside. If you take k outside, you will get L2 minus L1. Am I right?
yes,
L2 minus L1 is change in length. Am I right? That means change in distance. Am I right?
yes, you are right.
So I can write phi, which is equal to k multiplied by delta L.
Okay,
Am I right or not?
yes,
What is k? In chapter number 16, we studied the concept of angular wave number. Am I right?
Yes.
Am I right?
yes.
So
for
I
y
take
over
the
lambda.
formula, I substitute here. When you substitute, you will get. So this is the equation for the difference between phase difference and path difference. Clear?
What's
This
mean,
is your
doctor?
phase difference. This is your path difference. Okay?
Okay.
Clear? So when you use this equation for the phase difference and the path difference, you can get the information about the constructive interference and the destructive interference. So constructive interference, if you want to frame constructive interference, you have to use this relation. Actually, explanation for this relation is a very lengthy. I just took only the final answer. Clear?
Okay, yes, clear.
So when you substitute 0 here, you will get 0. When you substitute 1 in this equation, you will get is 2 pi. When you substitute 2, you will get 4. That means every even path difference, you will get constructive interference. That means the overlapping of two waves. When you take two waves combined together, you can either produce constructive interference or destructive interference. Understand?
Yes, it's clear now.
Okay,
Thank
that
you.
information is given here. Okay, so don't worry, just memorize the formula. We can ask only the theory question from this chapter, from this slide. Clear?
Yeah, clear.
Yes.
Clear, doctor.
Now, in this slide, we are going to study the concept of sound intensity. How to find the sound intensity? If you want to calculate the sound intensity, you must know what is the power of the wave. So sound intensity I, which is equal to the power of the sound wave divided by the area which the sound waves pass through. So P over A. So this is the formula for calculating the sound intensity. And also you have another formula for calculating the sound waves, which is equal to rho multiplied by V angular frequency square and the displacement amplitude square. So you have two formulas for this intensity. So what you have to do, if you have any question, if you got any question in your exam paper from this topic, sound intensity calculation, you have to read the question very carefully and you have to know what is given in the question. Based on the things given in the question, you have to choose the formula. Clear?
Clear. Doctors, I think it's come from chapter 16, the second
Where
one.
it comes from chapter number 16. Don't get confused about the power. Power there in chapter number 16, the power of the wave which is equal to mu v
Mu.
omega square ym square. Don't get confused
Mu
about
square.
this formula. Okay?
Yes, inertia.
This is your power of the wave. This is the intensity. Here you can see this mu is the linear density. Here rho is the medium density. That means density of the medium. Because here we are talking about the sound wave. My dear, here we are talking about the sound waves. Okay?
Okay, it's clear.
Okay. Where is
Okay,
the area
so-
go?
Yeah. In which area the sound wave is passing. So if you know the area, you can use that. Okay?
Okay.
Now,
Doctor,
in this slide, yes.
Doctor, what is SM?
What is the sound wave equation? S, which is equal to Sm cosine of kx minus omega t. Am I right? What is Sm?
I think amplitude.
Sound energy.
Amplitude of the displacement wave, because we are talking about the sound wave. Am I right?
Yes.
That means it's a displacement amplitude. Clear?
Yes, clear.
Okay. Now we are going to convert. How to convert the sound wave intensity from watt per meter square to decibel? So you have to use this rule. My dear, listen carefully. In many exams, we are asking the question from this slide. You know what the students they will do? They will forget to write this 10. So you should be very, very careful. If you forget to write the 10, your answer will be wrong. Understand?
Yes.
So please, while you write the formula, don't forget to write this value 10. So what is the formula for converting the sound intensity to decimal? 10 multiplied by logarithmic value of intensity of the concerned wave divided by the reference of the intensity reference. So you have three intensity value. You can just have a look of this slide. What is given in this slide?
Speed, sound for
We have the intensity level in decibel and its corresponding intensity in terms of watt per meter square. Okay? Clear?
yes,
clear.
Now you have to think, my dear, you are going to hear something by using your ears. Am I right? Because our ears will detect the sound waves. Am I right?
yes.
So our ears can detect from 0 decibel to the maximum of 140 decibel. So at 0 decibel, what is your threshold of hearing? From 0 onwards, your ears will sensing some sound. So your 0 decibel, which is equal to how much of watt per meter square? 10 to the power of minus 12. Am I right?
Yes.
You can use the formula converting watt per meter square into decibel. You have the, if you have a calculator, just use the formula 10 logarithmic value of I over I naught. Clear? So whenever you are going to use this formula, your reference value I naught is this. This is your reference value. Clear? 10 to the power of minus 12 is the reference I naught. So always this 10 to the power of minus 2 is your I naught value. Now you can see for the normal conversation, suppose you are talking to your family or you are talking to your friend, how much decibel you are using?
60.
60 decibel. This 60 decibel is equal to how much of watt per meter square?
10 power minus 6.
Minus 6. So if you just see this slide, I have this formula 10 multiplied by log of I over I naught. So what you are going to do, I am just giving an example here. Calculate the sound intensity of the person speaking. The person speaking is nothing but the normal conversation. Am I right? The person speaking is nothing but the normal conversation. Just before we said it is 60 decibel. Am I right?
Yes.
Yes.
So
Yes.
I'm going to use this formula 10 logarithmic of I over I naught. So if you want to get the normal speaking, what is the value of I value here? 10 to the power of 6. Am I right?
Yes.
Yes.
So substitute the value here. Substitute the value of 10 to the power of 6 here. What is I naught? Your I naught is the reference. Am I right?
Okay. Yes.
So when you substitute, what answer you got?
60.
60. That's
60.
60 decibel. So you can see this slide. This slide. The normal conversation is nothing but the person speaking. So 60 decibel, which is equal to this value. Am I right?
Yes.
Yes.
So likewise, if you ask any question from this slide, we will give the value of I as well as I naught. By substituting the values in the given formula, you have to find what should be its decibel value. Clear?
Doctor,
Yes.
why you said I naught is 10 to the power minus 12?
My dear, this is our lower level of hearing capacity. Your ears can hear from 0 decibel. Your 0 decibel, which is equal to 10 to the power of minus 12. That is your reference, starting value.
Okay.
If you want to compare something, you have to compare with some other else. Am I right?
Yes, yes.
For example, in our class, we have 2 students. So if you want to compare, you have to compare the students with the high marks. Am I right?
Yes.
Or you have to compare yourself with the lowest mark. Am I right?
Yes.
Yeah, right.
So likewise here, when you are about to convert that watt per meter square to decibel, you have to compare the sound waves from the threshold of hearing. How much your starting value? You can hear from 0 decibel. Clear?
Clear, yes, Doctor.
Yes. Yes.
Below 0 decibel, is it possible to hear?
So, doctor, I know
No.
is always
Ah.
constant, right? It's always 10 to
What?
the power minus 12.
Yes, my dear, listen carefully. Listen carefully. Below this 0 decibel or below this 10 to the power of minus
Yeah,
12,
I know,
is it possible to hear?
No, of course.
No.
So that means our starting value is 0 decibel or 10 to the power of minus 12 decibel. Clear?
Yeah.
Sorry, 10 to the power of minus 12 watt per meter square. So now you can see, my dear, you have 3 values. Just to keep these 3 information in your mind. 0 decibel, which is equal to 1 multiplied by 10 to the power of minus 12. Am I right?
Yes.
Middle 60 decibel, which is equal to 1
10
multiplied by
power
10 to the power of minus 6 watt per meter square. Am I right?
Yes.
What should be the maximum level of hearing? If you are hearing 120 decibel, you will get some pain in your ear. That means this is our maximum region. You can hear more than this, but what will happen to your ear? It will gone. Finally, you will get more pain in your ear. For example, you can see this. If you are near to the jet plane, what will happen, my dear? What should be the decibel?
140.
What will happen to your ear?
I get
You will get extreme pain on your ear. So these 3 values are very, very important. If you are getting 1 watt per meter square, you will get the maximum. That means the pain will start from 120 decibel. The pain will start from 120 decibel. But if you are hearing more than this, what will happen? Extreme pain you will get. Clear?
Doctors,
Yes,
Yeah.
doctor.
where is in this schedule? We know the I naught and the intensity level.
All these are I. Okay.
All these.
Clear? All these are I, and this is your I naught.
Always I naught 10 of power minus 12, right?
Yes, correct.
Okay.
Clear?
Clear.
Now, in this slide, again, we are going to play with the same type of game what we played in chapter number 16. Do you remember that? In chapter number 16, we used how to calculate the lambda. Am I right?
Yes. Lambda n.
Yes.
Just a minute. I have the slide here. We did something here, am I right? My dear, listen carefully. What is the difference between this slide and that slide? My dear, here n tells you the number of loop. How many loops you have here?
One.
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 How many loops you got here?
Two.
Two.
That means if you have n is equal to 1, that is called as first harmonic. So if you have n is equal to 1, you will get only one loop. Am I right?
Yes.
Yes, yes.
In chapter number 16, whatever the things we studied is related with the number of loops. Clear?
Clear.
But here in this chapter, what we are going to do is little bit different. So please listen carefully. So here what I am just having, I have a pipe. My dear, listen carefully. I have a pipe and two ends of the pipes are open. You can see here, this pipe is open here. This pipe is open here. Am I right? That means the two ends of the pipes are open. Am I right?
Yes.
Yes.
Second case, you have the pipe. One end of the pipe is closed and another end of the pipe is open. Clear? So for
Yes.
these two categories, we are going to find what should be the lambda for the sound waves. My dear, in chapter, just a minute, I can just open few more slides. So you can see here, if you have the sound waves in the pipe, for example, if you have the waves,
No problem, doctor. We get it.
sorry, my dear. I think, my dear, in my pen, I think there is no mistake. I think in my system, because I am using the desktop system. That's what the problem.
Yes, doctor. It's
Okay.
happened with the dynamics, doctor. Same problem.
Okay. So dynamics also. Who is taking dynamics?
Sirajuddin.
Ah, I don't know in the desktop, because in my laptop I never faced this issue.
Maybe the app you use. Change it.
Okay, no problem. Okay, my dear, this is the waves. Am I right? How many nodes you have here? How many antinodes you have here? Can you please tell me?
Eight.
How many nodes you have?
Eight.
How many antinodes you have? 1, 2, 3, 4, 5, 6, 7, 8 nodes you have. Am I right?
Yes.
How many antinodes you have? These are all antinodes. 1, 2,
Seven.
3, 4,
Seven.
5, 6, 7. So 7 antinodes you have, 8 nodes you have. My dear, listen carefully. If you have a pipe, if you have the pipe, if both ends are open, all the times your antinodes will be creating in the open end. Clear?
Yes.
If you have the pipe closed at one end and open at other end, all the times your nodes will be starting from the closed end. Keep this point in your mind, okay?
Repeat it, doctor.
Please, doctor, repeat
my dear, you have nodes and antinodes in the wave. Am I right?
We know
Yes.
the
Am I right?
nodes. What's mean anti-nodes?
My dear, listen carefully. You have a wave here. Am I right?
Yes.
If you have the wave, if you have the waves like this, I just draw the big size wave. This is your wave. Am I right?
Yes, you're right.
This is your wave. These are all the nodes. This part is called as nodes. Okay.
عقدة. Yes.
What is your antinodes? These are all your antinodes.
Okay.
Clear?
Clear.
Now, these nodes always happen in the closed end. If you have any closed end, your nodes will start from this point. Okay?
Okay.
And always your antinodes will be happened only in the open end. Okay?
Okay.
These things we are going to learn now. So please listen carefully. I am going to explain the concept of the pipe open at both ends and the concept of pipe one end is closed, another end is open. Let's we start from here. Okay, so I'm going to take a pipe, both ends are open. Now n is equal to 1. What is the meaning for n here?
Nodes.
Here
Number
n
of
stands for, my dear, listen carefully. Here n stand for nodes. Okay, in chapter number 16, n stand for loop. Clear?
yes, clear.
In chapter number 16, n stands for the loop. In chapter number 17, n stands for the nodes. So here I have n is equal to 1 means nodes is 1. I told you your nodes will never comes in the open end. Your nodes will comes only in the closed end. So I am going to draw only one loop here, only one nodes here. Clear? So if I just draw the wave, your wave will come like this. Am I right?
Yes.
See, in the open end you got the antinodes. Am I right or not?
Yes.
Now, the total length of the pipe is L. For example, can you please calculate the lambda? I have lambda over 4, 1 and another lambda over 4 here. Am I right?
Yes.
Therefore, my L, which is equal to 2 lambda over 4. Am I right?
Yes, lambda over 2.
This is lambda over 2. Therefore, my lambda, which is equal to 2L. Am I right?
Yes.
Yes, you are.
What we got here? Understand?
Yes.
Clear.
How many nodes we have here?
One. Just one.
One.
This is n is equal to 1. Here, how many nodes you have here?
2.
2.
So n is equal to 2. Here, how many nodes you have?
3.
3.
Here n is equal to 4. Am I right?
Yes.
Can we please play for this n is equal to 2? Draw a pipe. N is equal to 2 means how many nodes? 2 nodes. 1, 2. So if you just draw the waveform, it will be coming like this. Now how many lambdas you have? Lambda over 4. If you divide these two, you have 2 lambda over 4. Am I right?
Yes.
You have lambda over
Yes.
4. Therefore, my L, which is equal to 4 lambda over 4. Therefore, my lambda is equal to L. Am I right?
Teacher,
What we got here? Same. Am I right?
teacher,
Yes.
why we divided?
Where we, my dear, this is just for the explanation purpose. Don't see this, okay? Don't see this, huh?
No. In the last slide.
Which slide?
He means Dr. lambda over 4 2 times. You wrote it.
I couldn't
Yes.
get what you are saying.
In the previous slide.
Yes.
In the previous slide means chapter 16?
Yes.
In chapter number 16, we want to take the lambda, the general formula. This is our general formula. Am I right?
No, teacher, sorry. In the last slide, you explain this waves. Yes, here. Why we are divided?
My dear, in one loop, you have 2 quarters. Am I right?
Yes.
So that's what I divided. Just for showing you, I am just dividing. Otherwise, in a loop, you have lambda over 2.
Yes.
If you take one loop, how many lambdas you have here? Lambda over 4 and lambda over 4. Am I right?
Yes.
Which have lambda over 2. Am I right?
Right.
That's what I split this lambda over 2 into 2 parts. That is lambda over 4 and lambda over 4. For that purpose only, I'm just dividing. Clear?
Oh, yes, I get it. Thank you, teacher.
Okay. Now n is equal to 3. How many nodes?
3.
N is equal to 3.
nodes.
So 3 nodes. So I'm going to draw 1, 2, 3. So draw the waveform. Now how many lambdas you have, my dear? You can see here lambda over 4. Only you just have quarter. If you divide, you will get 2. Am I right?
On
Lambda
this,
over 4, lambda over 4. If you divide these two, lambda over 4, lambda over 4. Already quarter is here. Am I right?
6 lambda over 4.
Yes, L is equal to 6 lambda over 4, which is equal to 3 lambda over 2. Therefore, lambda, which is equal to 2L over 3. Am I right? Understand?
Yes, doctor.
Yes, yes.
Okay. Likewise, you can play for n is equal to 4. You can play for n is equal to 5. Likewise. Okay. Let's come for the second type. What type of tube you are going to have? One end is open, another end is closed. So I have a pipe. One end is closed, another end is open. Now n is equal to 1. How many nodes?
1.
So always your nodes will be start at the closed point. Am I right? So you have only one small wave. So L, which is equal to the length of the pipe, is L. So L, which is equal to only quarter wave you have. Am I right?
Yes.
So L is equal to lambda over 4. Therefore, lambda, which is equal to
4L.
we got 4L here. Clear?
Yes, clear.
Okay. Now n is equal to 2. N is equal to 2. 2 nodes. Node 1 and node 2 here. So what you will get? So here you have one complete loop, and here you have only half of the loop. So you can divide into 2. Am I right?
3 lambda over 4.
So L, which is equal to 3 lambda over 4, which is equal to, that means lambda, which is equal to 4L over 3. Am I right?
Yes.
Clear?
Yes.
So likewise, you can just play for n is equal to 3, n is equal to 4, and n is equal to 5. Clear?
So, teacher,
Yeah.
it's like the way which you taught us in the last chapter, but the only difference is in the pipe. Once it's closed from the other sides, and here it's closed from two. It's opened from two sides, or closed from one and open from.
If you have any question from chapter number 17 regarding the sound waves, if you have any question related with this type of diagram, keep the information in your mind. Always the nodes will start from the closed end, okay? And open it only the antinodes. Keep this point. That is quite enough for getting the correct answer, okay?
Doctor.
Yes.
Doctor, why we don't start from just one crust?
One class means what?
I mean, just one wave. I mean, one loop.
One wave.
One.
No.
My dear, but here they clearly mention n is equal to 1 here. What will be the case for the sound waves? All these are sound waves. We are just drawing with a green color line is the sound waves. When the sound waves, when you just move the piston to the right hand direction, actually here you have piston. You are just dragging in the outward direction. My dear, this week, some students you are going to do the standing waves experiment. Some students you are going to do the sound waves experiment. So if you are doing the sound wave experiment, we are going to play with this type of experiment. So don't worry. You will learn when you come for the lab. Okay?
Okay.
Clear?
Clear.
Doctor,
Oh.
how the question will be for this?
So you want to know the question?
I mean, how it will be?
Okay, I can do one thing. Right now I don't have the question. I can just frame one question. Tomorrow we have one period. Am I right?
Yes.
I will show that. Okay.
Okay. Thank you, Doctor.
Then you will get some idea.
Okay. Thank you.
Okay. Now we come for the last topic. My dear, this topic is very, very, very important in your quiz 1 and your midterm exam. For sure, one question will come from this topic, Doppler effect. So in our day-to-day life, we experience this Doppler effect. You can see this picture. The ambulance is coming. You are standing here. When the ambulance is coming towards you, you will get the sound waves greater. Am I right? The frequency of the sound wave you hear is more. Am I right or not?
Yes.
Yes.
When the ambulance is going away from you, the frequency of the sound you hear is less. Am I right?
Yes.
Yes, that's natural.
So when the ambulance is coming, your wavelengths are shorter. When the wavelengths are shorter, your frequency you hear will be more. When the ambulance is going away from you, the wavelengths are longer and the frequency you hear is lesser. Clear?
Yes.
Yes.
For calculating this Doppler effect, we are going to use the general formula for finding the frequency difference. So this is our general formula. What is our general formula? F dash, which is equal to V plus or minus Vd divided by V plus or minus Vs multiplied by F. My dear, listen carefully. We have the general formula for calculating the Doppler effect, and from this formula, how many formulas you can derive?
I think
How many
8.
formulas you can derive?
8.
Yeah, so 8 formulas are hidden here. So 8 formulas are inside. So you have to read the question very carefully. Now what is the difference? This F dash is the detector's frequency. For example, you can take, so he is the detector. So he is hearing something, am I right? So he is the detector. What is the source? Your ambulance is the source. So the frequency heard by the detector is F dash, and the frequency produced by the source is F. So what is your formula? Your formula is like this: F dash, which is equal to V plus or minus Vd divided by V plus or minus Vs multiplied by F. So this F dash is related with the detector, and this F is related with the source. Clear?
So, yes, doctor.
Okay, now let's we just go for finding the 8 cases. So my dear, listen carefully. I have 8 cases. Could you please recall the general formula? Could you please recall the general formula? F dash, which is equal to V plus or minus Vd divided by V plus or minus Vs. Am I right? Multiply by F. Am I right?
Yes.
Who is the director here? Who is the director here? In this picture? Tom is the director. Am I right?
Yes, Tom.
Who is the source?
Ambulance.
Ambulance. Okay, very good. Okay. Now, the frequency going to hear by Mr. Tom is F dash. Okay.
Okay.
The frequency he is going to hear is F dash. The frequency produced by the ambulance is F. Understand?
Yes.
Yes.
And here the ambulance is coming towards Mr. Tom. Am I right?
Yes.
Yes.
So this source has some speed. Am I right?
Yes.
Yes.
What is the speed? What is the detector speed? What is the detector speed?
0.
Why? Because he is at rest. Am I right?
Yes.
Yes.
Okay. Now you are very good. I think, my dear, listen carefully. So the detector speed is Vs, but sorry, the source speed is Vs. The detector speed is 0. So if you put 0, what will happen, my dear? This term will gone. Am I right?
Yes.
So what you have? F dash, which is equal to V divided by V plus or minus Vs multiplied by F. Am I right?
Yes, you are right.
Yes.
Okay. Now, when the ambulance is coming towards Mr. Tom, what frequency he will hear? Low frequency or high frequency?
High.
High.
Okay. If you want to get the high frequency, he has to use the positive sign or negative sign. Just tell me.
Yeah, to be close.
Positive.
My dear, Mr. Tom is going to hear some frequency. Am I right?
Yes.
Ambulance is coming towards Mr. Tom by producing some sound. Am I right?
Yes.
That means when the ambulance reached Mr. Tom will hear high frequency. Am I right or not?
Yes.
If you want to get the high frequency, you can just see this equation. You have numerator. This one is your numerator. This term is your denominator. Am I right?
Right.
Yeah.
So if your denominator will be greater, what will happen? If your denominator will be greater, what will happen?
Positive.
The frequency will be less.
The frequency will be less. Am I right or not?
Yes, you are.
If the frequency will be smaller, if the denominator will be the idea, listen carefully. If the denominator will be smaller, what will happen?
Smaller, the frequency will be less.
Will be high frequency.
My dear, still you are not getting. Here you have numerator and listen first. You have numerator. The first part, the top one is numerator and the bottom one is the denominator. Am I right? Don't consider this, and otherwise you will get confused about this n and d. The top one is the numerator and the bottom one is the denominator. Am I right?
Right.
Yes.
If your denominator value will be greater, what will be happen to your frequency here?
It will be less.
It will be less. But what Mr. Tom is going to hit? He is going to hear high frequency. Am I right or not?
Yes.
So if you want to get high frequency, your denominator must be small. Am I right or not?
Yes, you are right.
Yeah, yes.
So if your denominator must be small, what sign you have to prefer?
Minus.
Minus. Very good. So f dash, which is equal to v divided by, out of this positive and negative, I am going to choose only negative. Why? When the denominator will be smaller, my frequency here will be greater. Clear?
Okay, doctor. When we will use the positive.
Cases are coming. Just wait. Just I am starting only first case.
Oh, the first case when Tom he want here more.
My dear, here you have to see the condition. Mr. Tom is at rest. That means detector is at rest. Source is coming towards him. And when the source is coming towards the detector will hear the high frequency. For that, you will get this equation. Clear?
Clear.
Yeah.
Okay, let's come for case 2. Now what you observe from this picture? Mr. Tom is still at rest. But the ambulance is going away from him. So what frequency he will hear?
Less.
Yes, doctor.
Less. Am I right? Can you please recall the general formula? F dash, which is equal to V plus or minus Vd divided by V plus or minus Vs multiplied by F. Am I right?
Yes.
If the Tom is at rest, that means the detector is at rest. So what will happen to this Vd? This will gone. Am I right?
Yes.
So my equation becomes like this: V divided by V plus or minus Vs multiplied by F. Am I right?
Yes.
Now, when the ambulance is moving away from Mr. Tom, he will hear only less frequency. So if he want to get the less frequency, your denominator must be greater. Am I right?
Yes.
So what sign you have to prefer here?
Plus.
So f dash, which is equal to V divided by V plus Vs multiplied by F. Clear?
Sorry,
Clear,
doctor.
Clear?
Clear.
Doctor,
Yes.
why we delete VD?
Because detector is at rest. He is not moving.
Yeah, okay.
So what should be the speed of the detector?
0.
That's what I removed.
Yes, okay, thank you.
Clear?
Yes, clear.
Clear, my dear? So your case 1 and case 2 are perfect right now. Am I right?
Doctor,
Yes.
you remove the denominator here.
My dear, actually this is the problem of my pen. I'm not removing.
Oh, sorry.
I'm not removing anything. I'm extremely sorry, my dear. I face something different here.
Problem.
Clear? Now I think my formula is correct. Am I right or not?
Yes, you're right.
Okay. So case 1 and case 2 clear now. Am I right? Shall we go to case 3?
Yes.
Yes.
Okay. So this is our case 3. So what is here? Now my source is at rest. My detector is coming towards. Am I right?
Yes. Moving.
So general formula f dash, which is equal to V plus or minus Vd divided by V plus or minus Vs multiplied by F. Am I right? Now the detector
Yes.
have the speed, but my source is at rest. So what will happen to the source? This term will go on. Am I right?
Infinite, yes.
Yes.
Now
Yes,
Mr. Jerry is coming to us. Still the ambulance is emitting the sound, but Mr. Jerry is coming towards the ambulance. When Jerry is coming towards the ambulance, what frequency he will hear?
High frequency. High.
High frequency he will hear. Am I right?
Yes.
So
Yes,
this
yes.
equation, V plus or minus Vd divided by V multiplied by F. My dear, if you want to get high frequency, your numerator must be greater. Am I right?
Yes, positive.
Yes.
So we have to put only plus. Am I right?
Yes.
Minus 1.
Because if you put minus, your numerator will be smaller, your denominator will be greater, so your frequency will be more. So your frequency will be less. Am I right or not?
Yes, yes.
Yes, you're
You
right.
are.
So my equation is V plus Vd divided by V multiplied by F. So this is the case for the third case. Am I right?
Yes.
Yes.
Okay, let's we go for fourth case. What happened here?
Still the source at
Still source is at rest, but Mr. Jerry is moving away from the ambulance. That means the frequency he is going to hear is less. Am I right?
yes.
Yes.
So the general formula F dash, which is equal to V plus or minus Vd divided by V plus or minus Vs, but my source is at rest, so this Vs will gone. Am I right?
Yes.
So now the Jerry, so your equation becomes like this: V plus or minus Vd divided by V. Am I right?
Yes.
Yes.
So here Mr. Jerry is going to hear low frequency. So if you want to get low frequency, your numerator must be smaller. Am I right?
Yes.
So if you want to get smaller, you have to do only negative. Am I right or not?
Yes.
So
Yes, you're
my
right.
equation becomes V minus Vd divided by V multiplied by F. Am I right?
Yes,
Yes.
you're right.
Yes.
Clear?
Clear?
Is it clear?
Yes.
Yes,
Okay.
doctor.
Now, fifth case. What you understand from this picture?
Jerry and the ambulance move away.
So here the detector also have some. Listen carefully. Here the detector also have some speed. The source is also have some speed. Am I right?
Yes.
So I am writing the general formula V plus or minus Vd divided by V plus or minus Vs multiplied by F. My dear, both speed of the detector and the source have some value, so we cannot be able to delete anything. Am I right? The only thing we have to choose the sign. My dear, listen carefully. The ambulance is going in the left direction. The ambulance is going in the left direction. Mr. Jerry is moving in the right direction. Am I right?
Yes, you're right.
Yes,
So what frequency he will hear?
Minus.
Minus. And at the same time, my dear, listen carefully. At the same time, Mr. Jerry is moving away from this ambulance. Am I right?
Yes.
So what I am going to do, if you want to get the low frequency, because Mr. Jerry is going to get the low frequency, so your denominator must be smaller. Am I right?
Yes.
Yes.
So
Yes.
I can just use
Positive.
use positive sign. Am I right?
Yes.
Now you can see my ambulance is moving in this direction. Mr. Jerry is moving in the right direction. So he is moving away from this ambulance. So I have to put negative. If he is going towards the direction of the ambulance, positive. Am I right? If he is going away from the direction of the ambulance, negative. Clear?
Clear, yes. Clear.
So multiply by, yeah. Understand?
Yes.
Clear?
Can you repeat it, doctor?
You want to repeat this thing again? No problem.
Yes, please.
I will. This is your general formula. Am I right?
Yes, you are.
Okay. Now, my dear, ambulance left direction, Jerry right direction. Am I right?
Yes.
So what frequency he will hear?
Less.
Low frequency. So if you want to get low frequency, your denominator must be greater. Am I right?
Yes.
Am I right or not? So I can write the denominator first. What is my denominator? Plus. Am I right?
Yes, you are.
Okay, now ambulance is left direction. It is going left direction. Mr. Jerry is going away from the ambulance. So he is moving away. So what sign you will prefer?
Minus.
So I write minus. Clear?
Okay.
Clear?
Yes, and the positive because the
Positive means towards. Positive means towards.
Yes.
Clear?
So the bigger the domain value is, the smaller the frequency will be, right?
Yes, correct. Understand? Shall I go to the sixth case?
Yes.
Yes.
Okay, now you can see here ambulance is coming towards Mr. Jerry. Jerry is going towards the ambulance. Am I right?
Yes.
So what frequency he will hear?
Bigger. Opposite the case 5.
My dear, both, because he is going to meet this ambulance. So what frequency he will hear?
Bigger frequency.
So if you want to get bigger, your denominator must be smaller. Am I right?
Yes.
Yes.
So your general formula V plus or minus Vd divided by V plus or minus Vs multiplied by F. So if Mr. Jerry want to get high frequency, his denominator must be smaller. So what I just write with the denominator V minus Vs. Clear?
Clear, yes.
Now Mr. Jerry is going towards the direction of the ambulance because he is going to meet the ambulance. Am I right or not?
Yes.
Yes.
So what sign you will prefer?
Plus.
Positive.
Negative.
So V plus Vd multiplied by F. Clear?
Clear, yes. Easy.
Seventh case is a little bit different. Seventh case and eighth case are different. My dear, listen carefully. Mr. Jerry is moving in this direction, but ambulance is also moving towards the direction of the Jerry. But you can see what is the speed. Which speed is more? You can just see the arrow mark size. We already studied in chapter number 3, physics 1. If your arrow mark is small, your magnitude is small. If your arrow mark is big, your magnitude will be greater. Am I right?
Yes.
Yes.
So which one is coming with the high speed?
The ambulance.
That means when the ambulance is coming towards Jerry, Jerry will hear high frequency. Am I right?
Yes, you are.
Yes.
Am I right or not? So what is our general formula? V plus or minus Vd divided by V plus or minus Vs multiplied by F. Now you can see here, he is going to get the high frequency. So your denominator must be smaller. Am I right?
Yes.
Yeah.
Yes.
So first I write the denominator. So V minus Vs. Now you can see here, my dear, listen carefully. He is moving away. Even though the ambulance is coming towards him, he is moving away from the ambulance. Am I right or not?
Yeah.
Yes.
So what sign?
Minus.
Minus. So V minus Vd multiplied by F. Clear?
Clear, yes.
Yes, clear.
Okay, let's become for the last slide, last case. Now you can see ambulance overtake him. Ambulance is going away from him, but the ambulance speed is more. So you can see the picture. Ambulance is going away from this Jerry. So what frequency he will hear?
Less.
Less frequency. That means low frequency he will hear. Am I right? Okay. If you want to get the low frequency, your denominator must be bigger. Am I right?
Must be positive.
Must be bigger. So you have to choose positive value. Am I right? So I can just write the denominator first. So V plus Vs. Now he is going towards the direction of the ambulance. He is going towards the direction of the ambulance. That means what sign?
Positive.
So
Positive
V plus Vd multiplied by EF. Clear?
Clear.
That's it. Your chapter over.
Teacher, I have one question before we go to the problems.
Yes, my dear.
About this one, the Tom and Jerry cases. I'm afraid
Hmm.
in the quiz or in the exam, it will be quite different from what we have studied.
No, my dear, listen carefully, my dear. In
now
your
it's
exam, We will give three information. First of all, please listen carefully. We will give the information about the source and the detector clearly. Okay, it's like a story.
So it will come in theoretical or in like a sentence.
It will comes in the problematic question. That means numerical question. So when you read the question, you will get which one is coming towards you, which one is going away from you. So when you read the question, first please understand the question. We will give the question in the easiest way. Okay?
Inshallah.
Don't worry, my dear. Question will be very easier from this Doppler effect. My dear, listen carefully, but please don't forget about these 8 formulas. So read the question, which formula is exactly applicable for that question, write that formula, substitute the value, get the answer. Understand?
Yes, yes. I mean
Clear?
the arrow thing. I don't know about it. How will it come in sentence form?
Okay, I can do one thing. Tomorrow I can just give you some example. Okay, because tomorrow we have one more period. Am I right or not?
Yes.
Yes.
I will give you some sample question. Okay.
I repeat one thing, Doctor.
Yes.
If they are in the opposite direction, the denominator sign and the numerator cannot be the same sign.
My dear, if both are moving opposite direction,
Yes.
the jury will hear low frequency. Am I right?
Yes.
It will be coming like this. Am I right?
Yes.
So you can see when both are moving away from this, Mr. Jerry is hearing low frequency. So what sign? Your denominator must be greater. Am I right?
Yes, because low frequency.
Yes. And at the same time, you can see both are moving opposite to each other. That means he is moving in the right direction and the ambulance is moving in the left direction. So what sign in the numerator?
Minus.
That's what we choose, minus. Clear?
Clear, yes.
So my dear, chapter 2 is over. I think what's the time? I think your class will be finished by 1:50. Am I right?
Yes.
Yes.
Okay. So what's the time right now?
1:30.
1:30. So still we have some time. So tomorrow we have one period at 8th period. Am I right?
Yes.
Okay. So better we can solve some question.
Doctor,
Yes,
can
my
you
dear. Ask the question.
the 3 case 3?
What 3? Okay, case 3. Okay. This is your case 3.
Yes.
What do you want from this slide?
Can you repeat it, please?
Okay, now you can see my source is emitting some sound, but it is at rest. Am I right?
Yes.
That means my V of S is 0. Am I right?
Yes.
So this term will gone. Am I right or not?
Yes.
So I have this one. Now we have to choose in the numerator whether it is positive or negative. My dear, the ambulance is here. Mr. Jerry is coming towards the ambulance. Am I right?
High frequency.
So high frequency, and also he is moving towards the direction. Am I right or not? So positive sign.
Okay. Yes.
Clear?
Yes.
Okay. So my dear, listen carefully. Before I go to the numerical question, I have to talk to you about the quiz 1. For physics 2, only 2 chapters, chapter 16 and 17. Okay.
Okay.
Which week you want to write the quiz 2? Week number 3 or 4?
3, doctors. Better.
Week number 3 or 4? You can choose by yourself.
3, doctors.
3 because it will be before all the other exams of other exams.
Okay, that's
Before
clear.
the other exams.
Doctor, I think
We
three.
will have calculus exams.
Dr. Wait,
I can choose week number 3.
More quiz.
No.
We will discuss it,
Shall I choose?
Doctor, and then we will tell you. It's better.
My dear, listen carefully. Inshallah, by this week I will finish chapter number 17 because tomorrow we have one period. Am I right?
Yes.
Yes.
So tomorrow, that period, I will finish this chapter number 17. That means we are ready for the quiz 2 chapters. That means quiz 1 chapters. Quiz 1 we consider only 2 chapters. I have no issue if you write the quiz on week number 3 or 4. It's up to you, but you choose that.
Doctor, you can
teacher,
make
week 4 we
in a
have
blackboard,
calculus exam.
like choice this or this. You can make in
My dear,
blackboard, I think.
just tell me week 3 or 4.
Dr. Muhammad.
From my opinion, in week 4 we have calculus exam.
Okay.
But week 3 we didn't have.
So shall we conduct the quiz on week number 3?
Everyone is
I
free.
don't know. In the chat, a lot of students they say week 4.
I have no issue. Just tell me. I have no issue.
Doctors, we can you please do the like choice in a blackboard if you want this or this? I think you.
My dear, I can.
You can
My dear,
do
listen
it.
carefully. I have 56 students in a section. I can't take the voting here. You can just tell me the result right now. I'm extremely sorry because I have a lot of works.
Doctor, I think week 3 is better.
Yes, my dear, listen carefully. You know, if you write the quiz in week number 3, week number 4, you have to write many quizzes. Am I right?
Yes.
Yes.
So better you can prefer week number 3. It's up to you.
Okay. Okay. Number 3.
Okay, Doctor. Week 3.
My dear, question will be very easy. The question will come. My dear, listen first. The question will be coming only from chapter number 16 and 17.
Yes. Okay.
So don't worry. The question will be very easy for you.
Okay, good.
So my dear, listen carefully. I think week 3, I plan to conduct the quiz 1 in period number 8 of Monday.
Okay.
Clear?
Okay, great.
Yes, good.
Because we have one period on Monday, I am going to conduct the quiz exactly during our class time.
Okay, doctor.
So the duration of the exam will be exactly 40 minutes. Clear?
Clear. How many questions, doctor?
Doctor.
Maybe 10 or 11 questions. Small question will be there. All questions are multiple choice.
Okay, doctor.
All questions are multiple choice. My dear, the only thing you have to work out and you have to choose the correct answer. Okay?
Okay.
Will be easy, inshallah.
It will be very easy. If you prepare properly, your quiz 1 will be very, very easy.
Sunday or Monday, doctor?
Monday. I think Monday you have only one period. Am I right?
The quiz is online, doctor.
Yes, Doctor.
My dear, quiz 1 and quiz 2 will be online. Midterm exam and final exam on campus. In campus, you have to come and write the exam. Okay?
Okay, Doctor, I have a question.
Yes.
Question 11 in chapter 16, without us, right, in quiz 1.
No. Forget about question number 11. This is just a theory question. Don't worry about that question.
Okay.
Clear, my dear. That is purely theoretical question. So don't worry. Clear?
Sir,
Sir.
Will be at Monday at period 8 or 8 p.m.
My dear, period, my dear. This is not period 8 p.m. Period.
Okay.
This is 8 period. Okay. At least you asked this question.
How many questions, Doctor, will be the quiz?
Maybe 10 or 11 questions will be there.
Okay, the slide is enough for studying.
It's more than enough.
Okay. Thank you, Doctor, so much.
Clear? Okay, my dear. I think tomorrow we have one period. First 2 problems I will solve. It's very easy. Please listen carefully. Okay? Please listen.
Okay.
It's very easiest question. First 2 questions. Listen, my dear. What is given in the question? The diagnostic ultrasound of frequency 3.8 megahertz is used to examine tumors in the soft tissue. That means we are using the ultrasound technique for some medical applications. So you are using the sound waves of frequency. How much frequency you are using? How much of frequency you use? 3.8 mega. What is meant by mega?
Okay, multiply by 10.
10 power 6. Okay. So 10 power hertz megahertz. You are just using the frequency for curing these tumors in the soft tissue. what you are going to calculate? You have two questions. In first question, you are going to find the lambda in air. My dear, this is the sound wave. Listen carefully. This is the sound wave. You are going to find the lambda. Am I right?
Yes.
What is lambda? Lambda is the wavelength. Am I right? And what medium you are taking? What is your medium?
In air.
In the air.
Yeah. So what is the speed of the sound in air? What is the speed of the sound in air?
Multiply by frequency.
My dear, first of all, please give me the answer. We gave the frequency. Listen carefully. We gave the frequency value. What we are going to find? We are going to find the lambda wavelength. And what medium you are just going to use? You are going to use the air. That means you are going to use the speed of the sound in air. Am I right? So what is the speed of the sound in air? Because at different temperature, your speed of the sound will be different. Am I right or not? So here I gave the value of the speed of the sound in air as 348. Clear? 348 or 343? Okay, 343. So here the question I gave, my speed value will be 343. This is the constant value. So don't get worried. Huh? So 343 meter per second. Understand?
You will give us, Doctor, this?
Yes, we will give this value.
Okay.
Clear?
The sound of air
Yes.
we will give?
By using this frequency, by using the speed, what you are going to find?
The lambda.
What you are going to? Lambda. So what is the formula for calculating the speed? Speed which is equal to frequency multiplied by lambda. Am I right?
Yes. The lambda equal.
Therefore, lambda which is equal to speed over frequency. Am I right?
Yes.
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 So what is the speed? 343 divided by what is the frequency?
3.8.
Could you please tell me the answer? If you have a calculator, 343 divided by 3.8 multiplied by 10 to the power of 6. I got 9.026 multiplied by 10 to the power of minus 5. The unit is meter per, sorry, meter, the unit is meter. Am I right?
Yes.
Yes, you are.
Am I right or not?
Yes.
Yes,
Yes, you're
Wait,
right.
the velocity up there. Why? Okay, sorry. I
Clear?
read it 348.
343. I changed to 343. Clear?
Doctor,
Yes,
this speed will give it, right?
The speed of the sound in air will be given. So don't worry.
Okay.
Okay. Can you please answer the second question?
Change the speed. Just change the speed.
Yes. So same formula. Here we use the speed of the sound in air as 343. But here what speed they give?
1,500.
So V which is equal to frequency. V which is equal to frequency multiplied by lambda. Therefore, lambda which is equal to V over frequency. My speed is given as 1,500. My frequency is already given 3.8 multiplied by 10 to the power of 6. When you just work out, what you'll get?
3.947.
47, yes.
947.
3.947 multiplied by 10 to the power of 4. 3.947 multiplied by 10 to the power of
5.
Minus 4.
4.
That is the answer for the second question. Clear?
Yes.
Clear.
Clear.
You can see the answer. My dear, don't get confused about this answer. Both are correct. Here I just gave the answer in terms of micro. Understand? Both answers are correct. Okay?
Okay.
Just write the answer like this. Just write the answer like this. It will be more than enough for me. Okay?
Clear.
Clear?
Doctor, from where you get for the question A 34.3.
34?
Constant speed.
It's a constant. It's a constant value, my friend. Speed of the sound in the air is 343, constant.
Okay.
So we will give that value, okay?
Yes, thank you.
For this question like this, Doctor, will you give a fill blank or what?
Will give?
Fill the blanks.
لا
Fill
كلها
the blanks.
خيارات.
Right answer in a blank.
My dear, all questions are multiple choice question. Just to see which answer will be there, just choose that.
Oh, okay.
Clear?
Clear, yes.
Yes, clear.
Doctor,
Ah,
there will be theoretical questions.
yes, of course, some one or two definition will be there. But that question is also multiple choice question.
Okay.
All are multiple choice questions, so don't worry, huh?
Yes, yes. Thanks.
Okay, let's we solve this question, and up to this question we will stop. Could you please read the question? You have the sound wave of frequency 280 hertz. What is the frequency? 280 hertz, and it has an intensity of 1 microwatt per meter square. So what is your intensity? Micro, that means 1 multiplied by 10 to the power of minus 6 watt per meter square. Am I right?
Yes.
So what you are going to find? What you are going to find?
Let's do it.
That means you are going to find SM value. Am I right?
Yes, equation.
So you have two formula for intensity calculation. What are the two formula? I is equal to P over A and I is equal to rho V omega square SM square over 2. Which formula you will prefer?
The second one.
Second, because the first formula there is no information about the power and area, so I can't use this. I have to use only this. Am I right?
Yes.
Okay, can you please rearrange this equation in terms of amplitude square? So if you rearrange this, what you will get? SM square, which is equal to 2 multiplied by I divided by rho V omega square. Am I right?
Yes.
Yes.
So here this is SM square. Can you please take square root on both sides? If you take square root on both sides, what you will get?
We'll get
Square root of 2I square root of 2I divided by rho V omega square. Am I right?
Yes.
Okay, now you can see the question. Is there any information about this omega angular frequency?
No.
No.
So we have the relation omega which is equal to 2 pi f. Am I right?
Yes.
So by using this frequency, you can find the omega value. Am I right?
Yes, you are.
Take this omega. I value is given in the question. Density of the air is given. What is the density of the air? This is the constant. These both are constant. So don't worry. We will give this value in your exam. Okay?
Okay.
Yes.
So density of the air is a constant 1.21 and the speed of the sound in the air is 343 and omega, you have to use this relation to find the value of omega. Intensity value is given in the question. So when you substitute all the value here, you can easily find the amplitude. Am I right?
Yes.
Yes.
So you will get this answer. Understand?
Very clear.
That's
Yes.
it, my dear. I think the class is over now. But please take practice, inshallah. Next week, Monday, 8th period, you are going to write your quiz 3. Sorry, quiz 1. I'm sorry, quiz 1.
Okay,
Teacher.
My dear, listen carefully. Question will be very easy. Question will be very easy.
Doctor, the questions will be like this.
The question will be like this. You have to work out with the formula. You have to choose the correct answer.
Very, inshallah, it will be very easy. Inshallah.
So don't worry, it will be very easy. Try to get full mark. Try to get A plus in physics 2. It will be very easy, my dear.
Inshallah.
Inshallah, Doctor. Inshallah.
Inshallah.
That's it.
Thank you.
Doctor.
Yes,
Doctor.
And in physics too, is it common to get B plus and above, A and A plus?
My dear, you can get A plus. Why you are going for B plus? Go for A plus.
Inshallah.
Not like
Clear.
physics 1.
I told you already, physics 2 will be more easier than physics 1.
Alhamdulillah.
Inshallah, we get A plus, inshallah.
But you have to follow me instruction, okay?
Okay.
Yes.
If you follow me instruction, for sure you will get A plus.
Inshallah.
Thank you, doctor.
Get A plus. Thank you.
Okay, doctor. Thank you very
Okay,
much.
brother. See you tomorrow.
Thank you, doctor. Have a good day.
Doctor, I have a question.
Yes.
About changing the unit.
Yes.
You will give us same way what you gave us.
You mean changing of unit what?
For example, from micro to.
My dear, micro you already studied in chapter number, in physics 1, am I right?
Doctor, we talked for physics 1 before the summer. We forgot everything.
Okay, don't worry. But my dear, listen carefully. Micro and mega. Usually your question will be coming from micro, mega. Micro means 10 to the power of minus 6. Mega means 10 to the power of 6. That's it.
Okay, we talk it now.
Don't worry. It will be same like this. So don't worry.
Yeah.
It will be very easy for you.
Yes, okay, Doctor.
Clear?
Thank you so much.
Okay, my dear. See you tomorrow,
mega-
inshallah. Okay?
Teacher, just one quick question. The mega is 10 to the power of what?
Mega means 10 to the power of plus 6.
Plus 6. And micro is minus
Micro means 10 to the power of minus. Better I can just write it on the slides. My dear, just have a look of this slide, okay? Mega. What is mega?
Okay, Doctor.
10 to the power of plus 6. Micro. 10 to the power of minus 6. Okay? Kilo. 10 to the power of plus 3. Milli. 10 to the power of minus 3. Keep this information in your mind. Okay?
Okay. Thank you, doctor.
Okay, my dear. Thank you. Assalamu alaikum.
Thank you, doctor.
Wa alaikum salam.
See you tomorrow. Huh?
See you tomorrow, doctor. Thank you so much.
Inshallah. Assalamu alaikum.
Wa alaikum salam.